In the sweltering heat of a French summer afternoon, 3 miles southwest of St. Lo, Lieutenant General Omar Bradley stood with his arms folded across his chest, watching something extraordinary unfold before his eyes. A Sherman tank was backing away from a hedgerow, those impossible walls of earth and vegetation that had brought the American advance to a grinding halt for 6 brutal weeks. Around him, a carefully selected group of officers looked on with barely concealed skepticism. Major General Leonard Guerrero, commanding 5th Corps, stood shoulder to shoulder with various ordnance specialists who'd been called forward to witness what might be either a genuine breakthrough or yet another dead end in a series of desperate experiments. Welded to the tank's front were 4 steel prongs that jutted out like tusks. It was such a simple contraption that Bradley had initially dismissed it when the report first landed on his desk. But there was no time for skepticism anymore. The American breakout from Normandy was hanging by a thread, and when you're desperate enough, you try anything. The tank's engine roared to life, a deep mechanical growl that echoed across the Norman landscape. The driver shifted into gear and aimed the machine directly at the ancient bank of earth and tangled roots. The tank moved faster, 10 miles per hour, then 15. Those steel prongs made contact with the hedgerow in a sound like canvas being ripped apart, a noise that would become instantly familiar to tank crews across France in the weeks ahead. Earth exploded upward in a shower of dirt and debris, but the Sherman didn't climb. It didn't tilt backward. It drove straight through. The prongs carved into the base of that hedgerow like enormous knives cutting through fabric. Branches snapped and flew. Vegetation tore away from the earth. And then, in less than 5 seconds, the Sherman emerged on the far side, trailing broken limbs and shredded vines, but completely intact. The belly armor, that vulnerable underbelly that usually spelled a tank's doom, had never been exposed to enemy fire. Bradley's staff erupted. Officers were shouting, pointing, clapping one another on the back. Ordnance specialists were already scrambling forward to examine the breakthrough, measuring the gap, running their hands over the tank's hull, checking for damage. But Bradley himself remained quiet, his eyes fixed on the torn hedgerow. His mind was already racing ahead, calculating possibilities. If this device worked consistently, if it could be built in large numbers, if enough tanks could be fitted before Operation Cobra began, then maybe, just maybe, they could break through. The stalemate could end. He turned to Lieutenant Colonel John Madaris, his chief ordnance officer, and delivered words that would reshape the entire war. I want these devices manufactured and mounted on every tank we've got. Every Sherman, every Stuart, every tank destroyer capable of carrying one. Get them ready before Operation Cobra launches. Round-the-clock production. Use every ordnance unit, every maintenance depot, every welder available. This is the highest priority. What Bradley had just witnessed was the solution to a crisis threatening to transform the greatest amphibious invasion in history into a bloodbath that nobody could win. For 6 weeks, the bocage, those ancient Norman hedgerows, had stopped the most formidable army ever assembled. These hedgerows had proven deadlier than German concrete bunkers, more effective than minefields, more lethal than the entire Atlantic Wall. And the man responsible for solving this nearly impossible puzzle wasn't a decorated general with decades of experience or some MIT-trained engineer with advanced credentials. He was a 29-year-old sergeant from New Jersey who'd cobbled together a solution from scrap metal salvaged off German beach obstacles, armed with nothing more sophisticated than common sense, practical thinking, and a welding torch. This is the account of how Curtis Cullian's welding innovation broke the Normandy deadlock in just 7 days and opened the path toward Germany. 300 miles away, Supreme Commander Dwight David Eisenhower sat in his headquarters at Southwick House near Portsmouth, studying maps that painted a picture of deepening crisis. It was mid-June 1944. The D-Day landings had taken place only days earlier and had exceeded even the most hopeful estimates. The beaches at Omaha, where American troops had come terrifyingly close to being driven back into the ocean, had somehow held. By the end of that first day, more than 150,000 American, British, and Canadian troops had secured positions along 50 miles of French coastline. Within 7 days, the Allies had brought ashore over 300,000 troops, and formed a solid beachhead from the Cotentin Peninsula all the way to the Caen area. The greatest amphibious invasion ever mounted had smashed through Hitler's supposedly impenetrable Atlantic Wall. Fortress Europe, which Nazi propaganda had declared impossible to breach, had been penetrated. Yet the maps told a different story. The landings had succeeded, absolutely. The beaches were secure. Supplies were pouring ashore through the two Mulberry artificial harbours and directly across the sand. But the movement inland, that rapid push deep into French territory that was supposed to be happening, had stopped almost immediately. 2 weeks after D-Day, by mid-June, Allied forces controlled a beachhead barely 20 miles deep and 50 miles wide. Over 1 million troops had come ashore, but they were crammed into a narrow coastal strip, unable to move forward, losing thousands of men daily to small gains in ground. The entire invasion faced the genuine danger of devolving into the same kind of static, grinding trench warfare that had defined World War I. The strategic plan, developed carefully across 2 years of preparation, called for breaking out from the beachhead rapidly. British and Canadian troops were supposed to capture Caen, the crucial transportation hub, on D-Day itself, and push southward into tank country. American forces were to sweep across the Cotentin Peninsula, take the port of Cherbourg within 9 days, then swing south toward Brittany. Within 2 weeks, the Allied advance was meant to penetrate 15 miles inland across a continuous front, with mobile warfare, rapid breakthroughs, and armoured columns driving deep into German territory. That was the vision behind all the planning. Instead, the Allies found themselves trapped in vicious close-quarters fighting, advancing measured in yards rather than miles, bleeding thousands of soldiers for tiny scraps of territory. And there was a specific reason for this nightmare. It had a name: the bocage. On June 7th, just 1 day after the triumph at Omaha Beach, soldiers of the 1st Infantry Division, the Big Red One, began moving inland from the coast. They were worn out from the beach assault, having endured nearly 2,000 casualties in the landing itself, yet they were alive and had broken through the Atlantic Wall. They expected to find German forces in retreat, perhaps some hastily constructed defensive positions around villages and towns further inland. What they discovered instead was terrain that seemed designed by nature itself to favor those defending and destroy those attacking. A green labyrinth far more lethal than any German fortification they'd faced. Private James Henderson of the 26th Infantry Regiment wrote in his diary that first day, words that would surface decades later in the National Archives. "We thought we were through the worst once we left the beach. We had shattered the Atlantic Wall. We'd survived the worst Germany could send at us. Then we ran into these hedges, these damned Norman hedges. God help us. God help us all." The hedgerows weren't hedges in any way American soldiers understood them. They weren't the decorative shrub borders found in American suburban yards. They weren't agricultural dividers that could be trimmed or moved aside. These were ancient fortifications, built up across centuries by Norman farmers who had molded this landscape since medieval times. The process had started 1,000 years before, when farmers cleared their fields of stones and rocks, piling the debris along property lines to mark boundaries and contain livestock. Each generation added to these walls, more stone, more earth. Seeds fell from plants growing on top and took root. Trees began to sprout. Over centuries, those walls transformed into earthen banks, rising 3 to 12 feet high and 1 to 10 feet thick at the foundation. The soil in these banks was packed as hard as concrete, compressed by centuries of settlement and strengthened by root systems from trees and plants growing on the surface. On these earthen ramparts grew oak trees, hawthorn bushes, brambles, wild roses and thorns, all twisted together into barriers rising 15 feet above the earth foundation itself. The roots reached deep into the banks, many extending 10 or 15 feet down through the compressed earth, creating structures that were tougher than most man-made fortifications. These root systems were so thick and so thoroughly interwoven after generations of growth that the hedgerows couldn't be dug through without heavy machinery and couldn't be blasted apart without enormous explosions that would reveal American positions to every German soldier within miles. The hedgerows enclosed irregular fields that ranged wildly in size but typically measured 200 to 400 yards across. Some fields were nearly square, others stretched long and narrow, some were triangular. The pattern was completely unpredictable, the product of 1,000 years of inheritance customs, land division, and farming practices. Reconnaissance photographs taken in the weeks before D-Day had shown how extensive this problem truly was, though military intelligence hadn't fully grasped its tactical importance. One photograph showing just 8 square miles of the American sector near St. Lo revealed nearly 4,000 separate hedgerow-enclosed fields. Each field was a potential stronghold. Each hedgerow formed a defensive barrier, with thousands stretching across the entire American zone, from the coast to the Cottontan Peninsula and south towards St. Lo. For German defenders, every hedgerow became a ready-made position superior to anything military engineers could have built. Machine gun teams could dig firing positions into the earth banks, cutting small openings just large enough for the gun barrel that commanded the open fields below. These positions stayed invisible from more than a few yards away, shielded from artillery by the bank itself, resistant to everything except a direct hit from heavy guns. The vegetation on top offered perfect cover from aircraft observation. Reconnaissance planes overhead saw nothing but an endless green canopy. The thick earth banks sheltered soldiers from artillery fragments and rifle fire. A German soldier positioned behind a hedgerow was actually safer than one in a concrete pillbox, because pillboxes could be seen and targeted, while hedgerow positions stayed hidden until they opened fire. The defensive advantages were extraordinary. A single German squad, 8 or 9 men, well positioned behind a hedgerow with a machine gun and rifles, could control an entire field and hold back an American company of 200 soldiers for many hours. The Germans didn't need continuous defensive lines. They didn't have to defend every hedgerow. They simply stationed small groups throughout the bocage, creating layered defenses where each position supported the others. When American forces attacked across a field, they took fire not just from the hedgerow ahead, but from hedgerows on their flanks as well, creating a crossfire that transformed every field into a slaughter zone. American soldiers faced tactical challenges that seemed nearly impossible to solve with their available weapons and training. Infantry crossing the open fields were completely exposed. There was no shelter in the middle of a Norman field. No trees, no rocks, no hollows. Just open grass or crops, with German machine guns and rifles controlling every inch from positions invisible until they started shooting. The Germans had already calculated fields of fire for likely crossing points, marked distances, worked out angles, preparing to unleash fire the moment American troops left the previous hedgerow. The approach to the next hedgerow became a journey through fire that had been calculated in advance. In zones where German gunners didn't need to aim carefully, they simply fired at predetermined points and hit whatever appeared. The sunken lanes connecting the fields posed equal dangers. Carved deep into the earth by centuries of cart traffic, these narrow passages, some barely wide enough for a single vehicle, formed obvious routes for American advance and obvious targets for German ambush. The Germans would block these lanes with felled trees, debris from destroyed buildings, or simple earthen berms. Then they'd position machine guns to cover the blockades from hidden spots. American troops, trying to clear these narrow roads, were forced into tight corridors where a single machine gun could stop an entire platoon. American tanks, the Sherman medium tanks that were supposed to provide the key to fast-moving warfare and rapid advances, became essentially useless in the bocage. The Sherman was a respectable tank by any measure. Its 75mm gun could defeat any German tank at normal ranges. It was dependable, simple to maintain, and manufactured in quantities German factories couldn't match. American plants were producing Shermans at over 1,000 per month. Yet in the bocage, none of this mattered. Shermans couldn't get through the hedgerows. The earth banks were too thick, too solid, too heavily reinforced by root systems. A Sherman's gun could tear apart the vegetation on top, but that didn't create an opening large enough for the tank to pass. The earth base stayed intact. Frustrated tank commanders started attempting breaches by raw force. They'd back up for a running start, then accelerate straight at the hedgerow, betting the tank's weight and power could blast through or climb over. This approach was deadly. When a Sherman tried to ride up and over a hedgerow, the front would rise as the tank climbed the bank. The entire machine would tilt backward at angles of 30 or 40 degrees. The belly of a Sherman tank lay exposed and vulnerable. Beneath the tracks, between the iron treads, sat just 1 inch of steel armor. That thin plating had been designed to deflect fragments from mines, nothing more. It was never meant to stop dedicated anti-tank weapons. A German soldier carrying a Panzerfaust could simply walk into the next field and settle in to wait. The shoulder-fired anti-tank rocket had been distributed to German infantry by the thousands. When the Sherman engine roared to life, climbing the hedgerow, he would hear it coming. The front of the tank would rise above the vegetation, climbing higher, higher. Then that vulnerable belly would be exposed for just a moment. He would squeeze the trigger. One rocket. That was usually all it took. The Panzerfaust could punch through nearly 6 inches of armor plating. Against the Sherman's pitiful 1-inch belly plate, it was brutally effective. Lieutenant Colonel Wesley Yale commanded a tank battalion in the 2nd Armored Division. In a single morning, he watched 4 Sherman tanks get torn apart. They were trying to breach the hedgerows near the town of Isigny-sur-Mer. 4 tanks destroyed in hours, 4 crews killed or wounded, 16 men gone, and they hadn't broken through, not once. His report, filed on June 15th, captured the desperation and fury that every American armor officer felt in Normandy. "The enemy didn't even need to see our tanks to kill them," he wrote. "They hide in the next field, behind the next hedgerow, and wait for us. They listen for our engines. They hear us climbing. And when we reach the top, when our belly is exposed, they fire. We lose crews and machines to an enemy we never see, never fight, never get a chance to strike back. Our tanks, which should be our greatest strength, have become coffins in this cursed landscape." American commanders tried everything they'd learned in years of training. Combat engineers moved forward with explosives. They trained in demolitions and obstacle clearance. The theory was straightforward: plant TNT or Composition C, properly positioned, and you could blow a hole through even the thickest hedgerow, big enough for a Sherman to squeeze through. But theory and reality were 2 different things. First, it was agonizingly slow. Engineers had to move under fire, get to the hedgerow, place the charges, connect the detonators, retreat to safety, then blow. 10 to 15 minutes on a good day. Much longer when bullets were flying. Second, the explosions advertised American intentions to every German within miles. The Norman countryside was quiet, which meant those miles extended far. German machine gunners and mortar crews would zero their weapons on that gap the moment smoke cleared. Third, and worst of all, American infantry and tanks funneling through those blown breaches became sitting ducks. The narrow gap became a pre-marked killing zone. German gunners didn't hunt for targets. They just fired at the opening and hit whatever came through. Specialized vehicles offered no better solution. Bulldozer tanks, standard Shermans fitted with heavy steel blades on the front, had seemed promising. Originally designed to clear beach obstacles during amphibious landings, they were supposed to push through hedgerows and scrape passages open for following tanks. In practice, they became priority targets. These vehicles moved slower than regular Shermans. They couldn't maneuver as quickly. They were obvious, unmissable. German spotters would identify them immediately and direct anti-tank fire straight at them. Destroy the bulldozer, and you stop the American breakthrough attempt. The 75th Armored Division had landed with 14 bulldozer tanks. Within 3 weeks, 11 were gone, destroyed or crippled beyond repair. By early July, American forces had almost no bulldozer capacity remaining. The few that survived were being saved for critical missions only. Routine hedgerow clearing without them became impossible. 6 weeks after D-Day, late June 1944, the American advance had slowed to a crawl that measured progress in yards per hour, not miles per day. The price in human lives was staggering beyond comprehension. Official Army histories document that the 8th Corps, fighting through the bocage toward La Haye-du-Puy and Les Alissés, suffered over 10,000 casualties while advancing just 7 miles. Some secondary sources describe 1,000 casualties per kilometer for portions of this fighting, though those exact numbers remain difficult to verify from official records. What cannot be disputed is that American infantrymen were dying at rates that matched or exceeded the worst slaughters of World War I. Capturing Mont Castre, a hill overlooking the Cottontown Peninsula, cost American forces approximately 2,000 casualties in savage close-quarters fighting. The 1st Infantry Division, which had landed on Omaha Beach on D-Day, lost 75% of its frontline infantry in the first month. Companies that had arrived with 150 men were down to 30 or 40 effective soldiers. The 29th Division suffered equally devastating losses. This wasn't the mobile warfare planners had promised. This wasn't the rapid exploitation across France they'd envisioned. This was medieval combat where every field had to be taken, every hedgerow assaulted, every few hundred yards of earth paid for in American blood. America's industrial power and manpower reserves meant nothing here. These casualty rates couldn't be sustained indefinitely. The replacement system was cracking under strain. New soldiers arriving in Normandy had minimal training before being thrown into veteran units to replace the dead and wounded. Morale, high after the D-Day landings, was plummeting. Soldiers who'd survived the beach and thought they'd seen the worst combat could offer were being ground down by hedgerow brutality. General Omar Bradley commanded the 1st United States Army. He faced a crisis that threatened far more than his reputation. The entire invasion strategy hung in the balance. His forces were exhausted, demoralized, and bleeding irreplaceable infantrymen at unsustainable rates. British and Canadian forces to the east, fighting around Caen, were making equally limited progress against heavy German armor. Field Marshal Montgomery's plan to capture Caen on D-Day had collapsed completely. The city wouldn't fall until mid-July, more than a month late. The grand strategy guiding 2 years of planning, the vision of rapid breakout and mobile warfare across France, was crumbling into static trench warfare like World War I. Bradley's chief of staff, Major General Walter Bedell Smith, who also served as Eisenhower's chief of staff at Supreme Headquarters, described the situation with brutal honesty. A memorandum to Eisenhower captured the growing crisis. In southern Normandy, he wrote, "Every small field is a fortress. Every hedgerow is a German strongpoint. We're fighting World War I again, but the trenches are green and growing. Our mobility, our armor, our firepower, the terrain neutralizes all of it. The Germans trade space for casualties. They're winning that exchange. The German defense of Normandy worked because of its elegant simplicity. Rather than holding a continuous front line, which would have required troops they didn't have, German commanders positioned small groups throughout the bocage, using natural fortifications to create defensive depth that conventional tactics couldn't overcome. A typical German position consisted of 2 or 3 machine gun teams, a mortar crew, a handful of riflemen, 20 to 30 soldiers total. These small units held clusters of 3 or 4 hedgerows. They positioned themselves to create interlocking fire. Each position supported the others. When Americans attacked, Germans held fire until the attackers were fully committed, emerging from cover and crossing open fields. Then machine gun fire erupted. The MG-42 could fire 1,200 rounds per minute. Entire American platoons fell in seconds. Americans would take cover, call for artillery, try to locate German positions. By the time shells started falling, Germans had already moved to alternate positions in the next hedgerow. Americans attacked empty ground, while fire came from somewhere else entirely. German tactics exploited every advantage terrain offered. Machine gunners dug deep into hedgerow banks, creating small tunnels or caves with overhead protection from artillery and complete concealment. The firing port was barely 6 inches across, camouflaged with cut vegetation, invisible from more than a few feet away. A German gunner sat in complete safety, protected from anything except a direct hit from heavy artillery, and fired at exposed American troops with virtually zero risk. German snipers used trees growing on hedgerow tops to observe and pick off officers and sergeants. Losing small unit leaders devastated American effectiveness. A rifle company that lost experienced sergeants and lieutenants early couldn't recover even with replacement officers. New leaders didn't know their men, didn't know who could be trusted, didn't have the bonds that held units together under fire. German snipers knew this. They deliberately targeted anyone giving orders, carrying maps, operating radios. German positions were camouflaged with extraordinary discipline. Fresh branches replaced wilting camouflage each morning. Vehicle tracks were covered. They dug tunnels under hedgerows to create protected movement routes between positions, allowing entire squads to displace unseen. Some units dug elaborate trench networks connecting multiple hedgerows, underground passages that let men move from position to position, completely hidden from American observers and aircraft. The psychological toll on American troops was severe and cumulative. Men who'd survived Omaha Beach faced German machine guns and artillery during the landing, who thought they'd endured the worst combat imaginable, found hedgerow warfare even more terrifying. On the beach, at least the enemy was visible. You could see German bunkers. You could identify targets. You knew where fire came from. In hedgerows, death came unseen from positions that couldn't be found until they opened fire. Every field was potential death. Every advance across open ground became a journey into terror, waiting for the moment when machine gun fire would open up and cut you down before you could react. Captain Joseph Ewing served with the 175th Infantry Regiment of the 29th Division. His description of the approach to St. Lo captured the suffocating claustrophobia perfectly. After the war, he wrote that they advanced through a vast maze of natural fortifications stretching miles deep. Every hedgerow could hide an enemy, every field crossing could be fatal. They couldn't see more than one field ahead. They had no way to know where Germans were until they opened fire. The tension, the constant awareness that machine gun fire might erupt from invisible positions, wore men down faster than actual combat. Veterans became hollow-eyed and shaking. New replacements broke under strain within days. Into this desperate situation, where the entire Normandy campaign teetered on failure's edge, where casualties mounted by the thousands and no solution appeared possible, came an ordinary soldier with an extraordinary idea. Curtis Grubb Coolin III was 29 years old in the summer of 1944. A sergeant serving with the 102nd Cavalry Reconnaissance Squadron, part of the 102nd Cavalry Group operating under 5th Corps Command. He was nobody special in the vast American military hierarchy. He held no advanced degree. He'd received no engineering training. His background was entirely ordinary, the kind of American biography repeated millions of times across the armed forces. Coolin came from Frankfort, New Jersey, a small town about 15 miles west of New York City. His father worked as a salesman for a liquor distributor. Curtis attended local public schools and graduated from Cleveland High School in Frankfort in 1935. Before the war, he'd worked as a sales promotion assistant for Schenley Industries, the same liquor company employing his father. When war came, he'd enlisted in the New Jersey National Guard and been mobilized with his unit. He was trained as a tanker and driver. He knew how to maintain and operate Sherman tanks. He understood armored combat. But nothing in his background suggested he was about to solve a problem that had stumped the best military minds in America. What Curtis Coolin possessed couldn't be taught in classrooms or acquired through formal training. He had practical American ingenuity, the problem-solving ability born from growing up during the Great Depression when money was scarce and you learned to fix things yourself. You made do with whatever materials existed. You improvised solutions instead of waiting for someone else to fix your problems. This was particularly American, rooted in a culture valuing individual initiative and practical results over formal credentials and theoretical knowledge. The same spirit that drove American inventors for generations, from Benjamin Franklin experimenting with electricity to the Wright brothers building an airplane in a bicycle shop. In early July 1944, during a brief break from combat operations, soldiers from Coolin's unit gathered informally to discuss the hedgerow problem. A soldier struck a match in the darkness, lit a cigarette, and the conversation began. There was nothing formal about it. No official agenda, no structured planning session. Just men in uniform, worn down by weeks of combat, talking through their problems and frustrations. Tank drivers, riflemen, sergeants, officers, everyone had something to say about the impossible situation they faced. The talk drifted to the dead and wounded. Friends who wouldn't be coming home. Friends who'd lost limbs or their minds to the terror. They spoke about Sherman tanks that had been torn apart, trying to force their way through those massive earthen walls topped with vegetation. The hedgerows were everywhere, and they'd become a graveyard for American armor. Some of the soldiers threw out ideas, practical suggestions, wild theories, things that sounded more like fantasy than military solutions. Most got dismissed quickly, but then someone spoke up. A soldier from Tennessee, according to military historian Max Hastings, offered a thought that sounded crazy. Why not get saw teeth, he suggested, and bolt them to the front of a tank? Cut through these hedges like sawing wood. The soldiers around him laughed or rolled their eyes. Saw teeth on a tank. It sounded absurd, something from a comic strip, not from a real soldier with any sense. But Curtis Cullen was listening differently. The others heard nonsense. Cullen heard something underneath, a grain of mechanical truth buried in the crude suggestion. He didn't dismiss it with a laugh. Instead, he sat there thinking. If tanks couldn't climb over these walls without flipping belly up and getting torn open, and if brute force couldn't punch through solid earth reinforced by centuries of root systems, then maybe cutting through was the answer. Use the tank's own tremendous weight and engine power to drive steel blades into the base of the hedge, like a plow cutting through hard ground. Cullen's mind began working through the problem, piece by piece. He pictured steel prongs, tusks really, sticking forward from the tank's front. These prongs would angle slightly downward so that when a tank drove into a hedgerow, they'd bite into the earth at ground level instead of riding up and over it. As the tank powered forward at full throttle, those prongs would slice through roots and packed soil while the tank's weight kept it level, preventing the deadly tilt that exposed the vulnerable underside armor. The cut earth and vegetation would spray up and over the tank, but the tank itself would punch straight through at ground level. It was simple, it was elegant. It could work with technology they already had. But materials mattered. The prongs had to be tough enough to cut through deeply rooted earth, heavy enough to stay in place under enormous stress, but not so heavy they'd destroy the tank's suspension or kill its mobility. They needed top-grade steel that wouldn't bend or snap under the forces involved in ripping through a hedgerow. Where in Normandy in July 1944 could anyone find such steel? The answer was already there, scattered across the invasion beaches. 6 weeks earlier, German engineers had studied the Normandy coast with thousands of obstacles designed to shred landing craft. One of the most common was the Czech Hedgehog. 3 heavy steel I-beams, industrial-grade stuff about 6 feet long, welded together at crazy angles to form a 6-pointed contraption that looked like a massive child's jack. These obstacles were supposed to tear open the bottoms of landing craft or hold explosives. Instead, the invasion had swept right past them. They'd been pushed aside, blown to pieces, or simply abandoned. Thousands of Czech hedgehogs now lay rusting across the beaches, scattered in salvage yards, defeated and useless. The steel was excellent quality, already cut to workable lengths, available in limitless supply. This was exactly what Cullen needed. High-quality structural steel, ready to use, just sitting there. All he needed was the green light from his commanders and access to welding gear. Getting approval turned out to be surprisingly simple. Officers at every level of the American army in Normandy were desperate, absolutely desperate, for anything that might solve the hedgerow nightmare. When Cullen sketched out his idea and explained it to his company commander, showing where he planned to get the steel, the captain didn't hesitate. Permission granted. Within 2 days, Cullen had a Sherman tank at his disposal, welding equipment from maintenance, and authorization to gather steel beams from a salvage yard near Omaha Beach. The whole thing came together fast. By early July 1944, just 3 days of work produced the first prototype. Cullen's team selected 4 sections of I-beam from the salvage yard, each roughly 5 feet long and weighing about 100 pounds. They used cutting torches to shape the forward ends into sharp angles, creating points that would bite into earth and roots far more effectively than flat edges. They welded a crossbar to hold the 4 prongs in alignment, spacing them evenly across the tank's front hull. Then everything, prongs and crossbar together, got welded to the Sherman's lower front armor plate, angled downward just slightly. The result was crude. It was functional. 4 steel tusks pointing forward from the tank's hull, angled down about 10 degrees, ready to be driven into a hedgerow. The whole assembly added roughly 400 pounds. Enough to notice, not enough to wreck performance. The prongs stuck out 4 feet past the tank's normal profile, which meant drivers would have to be careful in tight spots. But if it worked, none of that mattered. The test happened on July 11, 1944, in a field not far from Omaha Beach. Around 20 soldiers gathered, mostly tankers and officers from Cullen's unit. Most expected failure. They'd watched too many hedge-cutting proposals collapse. A tank with welded-on steel seemed like another bad idea in a long line of bad ideas, but they were curious enough to stick around and watch it fall apart. The hedgerow they chose wasn't some weak test case. It was typical of the terrain they faced every day. 4 feet of solid earth and bank at ground level, then another 15 feet of thick brush and mature oak trees, the trunks thick as a man's arm. If Cullen's device could breach this, it could breach most of what Normandy had to offer. A Pennsylvania corporal, his name lost to history, settled into the driver's seat. He was nervous. If this went wrong, if the tank reared up like it had so many times before, he and his crew might become casualties. But he'd talked with Sergeant Cullen. The sergeant understood the mechanics. He seemed confident. The driver shifted into gear, fed throttle, and aimed straight at the hedgerow. 5 miles per hour, 8, 10. The prongs hit first, and the earth screamed. That's what it sounded like, a deep ripping, heavy canvas tearing as steel bit into solid ground. The prongs penetrated deep. For an instant the tank seemed to hesitate, might stall, might get stopped cold. Then the engine roared louder. The driver pushed the throttle all the way forward. The treads found purchase and pushed. Earth erupted upward in a fountain, blasted over the tank's hull. Branches snapped like twigs. Tree trunks splintered. Vegetation rained down on the turret and engine deck. And in less than 5 seconds, before anyone fully grasped what they were seeing, the Sherman punched completely through to the other side, broken branches trailing behind it, torn roots hanging from the prongs, the tank otherwise untouched. The watching soldiers couldn't hold back. They shouted, they cheered. Some had tears streaming down their faces, not from sadness, but from relief and sudden hope. 6 weeks of watching friends die. 6 weeks of feeling helpless against something that seemed unbeatable. And now, in less than 5 seconds, a piece of scrap metal welded by hand had changed everything. The tankers rushed at Cullen, grabbing his hand, slapping his back, thanking him with an intensity that made the quiet sergeant blush. The officers were already thinking ahead. If it worked once, it could work again. If they could modify one tank, they could modify them all. If manufacturing was as straightforward as it looked, maybe the entire American armor force could be equipped before the next big push. But one successful test, no matter how dramatic, couldn't reshape a military campaign on its own. The device had to prove itself again and again under all kinds of conditions. Over the next 2 days, more tests followed. Different hedgerows, different approaches, different speeds. Every single test succeeded. The device was reliable, it was predictable, it was safe. Tank crews figured out the best technique quickly, come in around 10 to 12 miles per hour, aim straight at the target, pour on full throttle at impact. The tank would shudder as the prongs bit, but it would drive straight through. Ground level, belly armor untouched. Breakthrough time 5 to 8 seconds from initial contact to emerging on the far side. Word spread through the 2nd Armored Division, then beyond. Within 3 days of that first test, Major General Edward Brooks, commanding the division, had seen the reports. He understood what he was looking at. A real breakthrough. Brooks immediately grasped that this needed to go higher, to the one man whose approval could trigger mass production and force-wide equipment. On July 13th, Brooks sent a message to 1st Army headquarters requesting a demonstration for Lieutenant General Omar Bradley. Bradley had been buried under reports and complaints about the stalled offensive. He'd heard about proposed solutions before. All of them had failed. He was skeptical, but Brooks insisted this was different, and Bradley trusted his division commanders. He agreed to make the trip on July 14, 1944. Bradley arrived with his group, Major General Leonard Jarrow from 5th Corps and several ordnance specialists. 2 tanks had been prepared, both equipped with Cullen's device, an M5A1 Stuart light tank and a Sherman medium tank. The hedgerow for the demonstration was carefully selected. Typical bocage terrain, 5 feet of solid earth, crowned with thick brush and mature trees. The kind of obstacle that had stopped American advances for 6 weeks. Bradley and his officers positioned themselves where they could see clearly and safely. The light tank went first, backing up to build speed, then accelerating straight at the hedgerow. Impact. The sound of ripping earth, dirt and roots exploding upward. The tank burst through in less than 5 seconds. The Sherman went next, its greater weight and power driving through like the earth was soft clay rather than ancient root-bound soil. Bradley stood silent for a moment, his mind racing through the implications. 6 weeks of stalemate, thousands of casualties, an offensive about to launch that could fail if tanks couldn't move through this terrain. And here, demonstrated twice in 2 minutes, was the answer. Simple, reliable, buildable with materials on hand. Bradley turned to his ordnance chief and gave the orders. The conversation lasted maybe 10 minutes, but it set in motion a manufacturing effort that had no equal for speed and scale. Bradley had made it clear that these devices needed to be fitted to as many tanks as humanly possible before the offensive kicked off. The operation was set to launch in just 11 days, July 25th. That gave his teams 11 days to manufacture hundreds of these contraptions, get them transported to units scattered all over Normandy, and weld them permanently onto tank hulls. It meant production going around the clock, no breaks, no let-up. It meant pulling in every ordnance unit, every maintenance depot, every welder who could hold a torch in the American sector. It meant creating a mass production system from scratch for a device that barely existed a week earlier. Lieutenant Colonel John Medaris, the 1st Army Ordnance Officer, received the job directly. He was personally responsible for making this manufacturing program happen. He'd graduated from West Point back in 1930 and had spent years in logistics and materials management. A professional officer who understood immediately this wasn't going to be some routine production run. This was an emergency operation that could very well decide how the entire Normandy campaign turned out. Medaris got back to his headquarters and within hours had put out orders that would launch the fastest military production push the entire war had seen. Every ordnance company, every maintenance battalion, every repair depot scattered across the American sector received orders on July 14th to start making these hedge-cutting devices right away. The specifications went out by telephone and radio. 4 steel prongs, each roughly 5 feet long, made from salvaged German beach obstacles, with beveled edges sharpened at the front. A crossbar to keep the prongs lined up, the whole thing welded directly to the lower front of the tank hull. Simple enough that any decent welder could build it, but complicated enough that it needed real skill and attention to make sure those welds would hold when the tank hit something at full speed. Steel was everywhere, plenty of it. Behind the beaches, salvage yards were stacked high with thousands of tons of metal from smashed German obstacles. Trucks rolled out loaded with steel beams, hauling them to ordnance units across Normandy. The beams arrived bundled together, still crusted with rust and barnacles, scarred from their time underwater. Many bore scars from explosives or shell fragments. Ordnance crews would comb through the piles, picking out the straight pieces without damage, throwing aside anything that showed cracks or serious corrosion. The good beams got cut to length with acetylene torches, the ends beveled, then stacked ready for the welders. The welding itself was absolutely brutal work. Normandy in July 1944 turned sweltering, temperatures pushing into the 80s and 90s Fahrenheit. Welders dressed in heavy leather, face shields down, gloves on, handling steel beams that each weighed well over 100 pounds. The work happened outdoors or under canvas shelter because there wasn't time to build proper workshops. Each device took multiple hours of welding. The 4 prongs had to be welded to that crossbar. The crossbar had to be welded to the tank. Every single weld had to be strong enough to handle the enormous forces a tank generates when it barrels into a hedge at top speed. A weak weld could snap right at impact, and then the tank would end up stuck on the obstacle exactly like an unmodified tank would. The ordnance units operated in rotating shifts, working the clock around. Welders did 6-hour stretches, then stepped back while fresh crews took over. Acetylene tanks and welding rods had to be constantly trucked in to keep production moving. When one company started running low on supplies, trucks would shuttle materials from units that had extras. The whole system ran on the kind of flexible thinking that American military logistics could do better than anybody. No fancy master plans, no carefully worked-out production schedules. Just the pressing need to turn out as many devices as possible before Operation Cobra went live. Tank crews would drive their vehicles up to the nearest ordnance facility, wait while the device got fabricated and bolted on, then drive back to their units. Some crews sat around for 6 or 8 hours. Others waited through the night, but they waited because they knew this thing might keep them alive. Tankers who'd seen friends die when tanks flipped over on hedges understood that this device could prevent those deaths. They'd wait however long it took. Modified tanks started showing up in combat units around mid-July. At first, just a handful per battalion. Crews lucky enough to have modified tanks volunteered for the riskiest missions, testing these devices under real combat conditions. The reports came back consistently positive. The devices performed exactly as designed. Tanks punched through hedges in seconds without exposing their belly to fire. Commanders had choices about which direction to go instead of being stuck following roads or hunting for gaps that German guns might be covering. That kind of tactical freedom changed everything. By July 20th, 5 days before Operation Cobra, about 300 tanks in First Army had been equipped with these devices. That was roughly 15% of American armor in the area. Not nearly enough. Bradley wanted more production. Medaris pushed harder. He diverted more ordnance units from whatever else they were doing. More welders got pulled away from maintenance and sent to making hedgerow cutters. Things got frantic, desperate, everyone driven by knowing Operation Cobra was coming and every unmodified tank might get stuck and picked apart by German guns. By July 24th, the day before Operation Cobra launched, approximately 500 devices had been built and welded onto American tanks. That came to nearly 60% of the Sherman medium tanks, Stuart light tanks, and M10 tank destroyers that would go into the offensive. Not 100%. There simply hadn't been enough time. But it was enough. Enough to give American armor the freedom to move, enough to get tactical flexibility back, enough to break the deadlock. The tanks looked intimidating with their new gear. Those 4 steel prongs sticking out from each hull gave the Shermans a fierce, almost hunting animal look. Troops started calling them rhino tanks, the obvious reference to those African animals with horns. Others said rhinoceros tanks. The names caught on fast. Within days, everybody in the American Army knew what a rhino tank was. British forces saw what the Americans were doing and understood it made sense, so they quickly built their own versions. British ordnance units made prongs and fabricated them from German beach obstacles the same way. By August, British prongs were getting welded to Shermans in the British sector, though British production never matched the American output. The Germans faced these rhino tanks in actual fighting for the first time during Operation Cobra, and they had no official name for them. German after-action reports and interrogation statements mention them as American hedgerow tanks, tanks with steel horns, or just modified Shermans. What comes through clearly from German accounts is that encountering these things was a nasty shock. German tactics in the bocage depended heavily on assuming American tanks couldn't move well through hedgerow country. When that assumption fell apart, German defenses crumbled much faster than expected. The final days before Operation Cobra were pure frenzy. Infantry rehearsed their assault moves. Artillery officers registered guns on their planned targets. Air Force liaison people coordinated with ground troops to organize close air support. Meanwhile, across the American sector, hundreds of Shermans with freshly welded steel prongs ran final tests. Crews training on hedgerow breaking techniques, getting ready so that when the offensive started, armor could push through any opening the infantry and air power created. July 25, 1944, 9:40 in the morning. The sky above Normandy filled with engine roar. More than 1,500 B-17 Flying Fortress and B-24 Liberator heavy bombers, in formations so enormous they blocked out sunlight, approached their targets in a rectangle northwest of St. Lo. These bombers had lifted off from English bases hours earlier, climbing to altitude over the channel, forming up into those massive formations, then heading south across the invasion beaches toward their assigned zones. The carpet bombing target was a rectangle roughly 5 miles long and 1.5 miles wide between Montreuil and Hebec-Revon. This sector was held by German forces directly blocking the planned American push. The bombing was supposed to pulverize German defenses, destroy the command network, kill or stun German troops, and create enough confusion to let American ground forces drive deep into German territory before organized resistance could form. At exactly 9:40, the bombardment started. The first bomber groups dropped their loads from high altitude. High explosives and fragmentation bombs rained down like deadly hail. The ground effect was absolutely catastrophic. 500-pound bombs, 1,000-pound bombs, even 2,000-pound bombs went off one after another. The earth convulsed, trees snapped into splinters, hedgerows disappeared, buildings crumbled. German soldiers caught exposed or in weak shelters died instantly from the blast or got torn apart by fragments. The ones who survived the initial explosions climbed out deaf, numb, unable to think or respond. The bombing ran for nearly an hour straight. Wave after wave of heavy bombers passed overhead, each releasing its load, then banking back toward England. Behind them came roughly 1,000 medium bombers and fighter bombers, loaded with incendiary bombs and more high explosives. When the last plane turned for home, about 3,300 tons of high explosives and 60,000 incendiary bombs had been dropped. The bombardment saturated 12 square kilometers at roughly 5,000 bombs per square kilometer. The landscape became a moonscape of overlapping bomb craters, shattered trees, and burning wreckage. But the accuracy bombardiers hoped for just wasn't possible. The target sat close to American lines, separated in some spots by only a couple hundred yards. Thick clouds blocked the view, bombs were aimed by radar and dead reckoning, neither method especially accurate in the best conditions. Some bombs fell short, landing instead on American positions. The consequences were tragic. 111 American soldiers died, and nearly 500 got wounded by their own air force. Among the dead was Lieutenant General Leslie McNair, watching the bombardment from up front with the 31st Infantry Division. McNair was the highest-ranking American officer killed in European combat during the whole war. He held the rank of Lieutenant General when he died, though he'd get promoted to full general after his death. His death crushed American morale and served as a grim reminder of how dangerous close air support could be. The friendly fire casualties on the 25th added to casualties from a similar incident the day before, when aircraft had released bombs before getting their abort orders, killing and wounding over 150 Americans. Friendly fire casualties from the entire bombardment topped 800 killed and wounded. Even with these horrible losses, the bombardment did what it was supposed to. German defenses in that sector got effectively obliterated. The Panzer Lehr Division, one of Germany's best-equipped armored formations, was reduced to a fraction of what it had been. Its commander, General Fritz Bayerlein, described what he saw in words that captured the sheer shocking violence. "I observed a rolling cloud of dust with fountains of earth shooting upward. My front lines looked like the moon's surface, and at least 70% of my troops were finished. Dead, wounded, crazy, or in shock. Approximately 1,000 German soldiers were killed, dozens of command posts vanished, destroying the command structure that coordinated German defenses. Communications got cut off, telephone lines snapped from explosions, radio antennas toppled. Officers trying to issue orders discovered they couldn't reach their units. Survivors climbed out of their bunkers dazed, deaf, many suffering from blast shock and concussion. German defensive positions that had held up against weeks of American assault got wiped out in less than an hour. Into that chaos, American ground forces pushed forward. Major General J. Lawton Collins gripped the reins of the 7th Corps with a commander's confidence that came from understanding warfare at its deepest level. He was aggressive, competent, and relentless in his pursuit of military objectives. Speed mattered to him. Victory demanded momentum. He had earned his nickname Lightning Joe, fighting across the Pacific, and that handle said everything about how he approached combat. With velocity, with overwhelming force, with the kind of tactical aggression that turned battles into breakthroughs. Under his command stood 3 infantry divisions poised to strike southward. The 4th Infantry Division held the right flank, anchoring the assault's eastern edge. The 9th Infantry Division occupied the center, forming the spearhead of the main attack. The 30th Infantry Division deployed on the left, establishing the western boundary of the offensive. All 3 divisions had been bleeding in Normandy since D-Day itself. They were scarred, exhausted, yet grimly resolute. Their objective was straightforward but demanding. Attack southward from positions near St. Lo, punch through German defenses weakened by the massive bombardment, and carve open a corridor wide enough for American armor to pour through and exploit the breakthrough. Behind these infantry units waited 2 armored divisions, ready to unleash their full destructive potential. Major General Edward Brooks commanded the 2nd Armored Division, nicknamed Hell on Wheels. Major General Leroy Watson led the 3rd Armored Division, known as the Spearhead Division. These 2 formations held the bulk of American tank strength committed to Operation Cobra, and crucially, roughly 60% of their Sherman tanks carried Curtis Cullen's Hedgerow cutting devices. The mechanical innovation that would alter everything. The infantry assault kicked off in early afternoon on July 25th, several hours after the bombing concluded. American troops moved out across the scarred and cratered landscape, advancing cautiously at first, weapons ready, anticipating German counterattacks that never materialized with expected force. The German resistance proved fragmented and weak. Survivors of the bombardment sat dazed in shell craters, struggling to comprehend the destruction around them. Those who tried to fight discovered their weapons buried under rubble or their ammunition depleted. Communication had shattered completely. German officers attempting to organize any kind of coordinated defense found themselves cut off from higher command, unable to speak with neighboring units, isolated in the chaos. That first day's advance pushed forward approximately 1 mile, slower than commanders had hoped, a sobering reminder that even a bombing campaign of that magnitude hadn't eliminated German fighting spirit entirely. Hedgerows, damaged though they were, still offered defensive value. American infantrymen still had to advance carefully through fields, clearing German positions in brutal close-quarters combat. But this wasn't the organized, layered defense that had checked previous American offensives. This was fragmented fighting, scattered soldiers making individual stands, acts of courage or desperation, rather than systematic defense in depth. Major General Collins, observing from his forward command post, grasped something crucial that others might have overlooked. The German resistance was deadly, yes, but it lacked coherence. There was no defensive master plan being executed, no coordinated counterattacks, no systematic effort to establish new defensive lines. The bombing had destroyed the German command structure. Units fought in isolation, without support, without direction, without hope of coordination with anyone else. The German front wasn't bending under American pressure. It was fracturing, crumbling, collapsing. Late afternoon on July 25th, Collins made a decision that transformed Operation Cobra from a measured offensive into something far more ambitious. He ordered his 2 armored divisions to begin their exploitation immediately, disregarding the original schedule. The original plan called for infantry to establish a substantial corridor before armor pushed forward. But Collins recognized that delay was dangerous. Delay meant giving Germans time to recover from shock, time to establish new defensive positions, time to rush reinforcements into the gap. He made his gamble, commit the armor now, while Germans were still reeling, while chaos still reigned, and pray that American tanks could exploit the disorder before German defenses crystallized. The armored exploitation began at dawn on July 26th. Combat Command A of the 2nd Armored Division, led by Brigadier General Maurice Rose, drove south from the St. Lo area with orders to advance as rapidly as possible with no limits on how far to push. Rose was an aggressive commander who grasped armored warfare instinctively and understood how to exploit chaos. His column rolled forward with Sherman tanks, tank destroyers, armored infantry mounted on half-tracks, and self-propelled guns. Most importantly, the majority of his tanks carried Cullen's Hedgerow devices. For the first time since D-Day, American armor operated with genuine mobility and freedom of movement in the Norman bocage. The Rhino tanks crashed through hedgerow after hedgerow, selecting their own routes, bypassing German strongpoints, exploiting gaps in the disintegrated German defenses. Tank commanders no longer hugged established roads where German anti-tank guns might be waiting in ambush. They no longer searched desperately for passages through hedges that German fire covered. They simply drove cross-country, breaching obstacles at will, maintaining relentless momentum, preventing Germans from establishing fresh defensive positions. The psychological effect on German defenders proved catastrophic. For 6 weeks, they had relied on hedgerows as their fundamental advantage. They had used them to channel American attacks into predetermined killing zones. They had positioned anti-tank weapons to cover every passage. Now, suddenly, impossibly, American tanks appeared from unexpected directions, smashing through hedgerows that Germans had considered impassable barriers. The entire German defensive system, carefully constructed over weeks of brutal fighting, became obsolete in a single day. German counterattacks disintegrated into futility. Small groups of German infantry attempted to block American advances, but found themselves bypassed and cut off as American tanks drove through hedgerows on either flank. German anti-tank guns, positioned meticulously to cover known passages, discovered their firing lanes blocked by hedgerows, while American tanks emerged from unanticipated directions. German officers attempting to coordinate defense found themselves unable to predict where American armor would strike next. By midday on July 26th, lead elements of the 2nd Armored Division had advanced 6 miles beyond the start line, 6 miles in half a day. This exceeded the entire First Army's progress over the previous 2 weeks of grinding traditional warfare. The contrast was stark and electrifying. The town of Marigny, a significant road junction, fell to the 1st Infantry Division, supported by the 3rd Armored Division. German prisoners arrived in such overwhelming numbers, many of them fresh reinforcements from German training units, that American soldiers simply directed them toward the rear, without guards. There weren't enough military police to process them all. A senior non-commissioned officer in a German medical unit, identified in captured documents only as Klein, wrote in his diary that evening, "Today we understood that everything is lost. The Americans have broken through. Their tanks are everywhere. They come from directions we thought impossible. Our defensive positions that held for weeks are suddenly worthless. The men speak in ways that would have been unthinkable a week ago. They speak of survival, not victory. They speak of escape, not defense. Morale has collapsed overnight." July 27th brought accelerating momentum. The 30th Infantry Division, which had suffered the worst of the friendly fire casualties on July 25th, reported in words that would become famous, "This thing has busted wide open." The 3rd Armored Division reached the area around Coutances, a critical road junction approximately 15 miles behind what had been the German front line just 2 days before. German forces attempting to withdraw southward to avoid encirclement found their escape routes already blocked by American armor that had penetrated deep into their rear. Entire German units found themselves surrounded, destroyed, or forced to lay down weapons. By July 28th, the breakthrough had exceeded even Bradley's optimistic expectations. American forces had penetrated more than 20 miles beyond the start line in just 3 days. The German 7th Army, which had fought Americans to a standstill for 6 weeks in the bocage, was in complete retreat. Units scattered, command structure shattered, ability to conduct coordinated defense destroyed. The bocage, that nightmare terrain that had seemed to make sustained offensive operations impossible, now lay behind American lines. Ahead stretched the relatively open country of central France, where American mobility and firepower could operate without restriction. Post-battle analysis by American intelligence officers revealed the hedgerow-cutting device's decisive role. Staff officers examined after-action reports, interviewed commanders, compiled statistics on every successful hedgerow breach. The conclusion emerged crystal clear. Approximately 70% of successful hedgerow breaches during Operation Cobra were accomplished by tanks equipped with Cullen's devices. The remaining 30% required engineer support using explosives, bulldozers, or manual labor, all significantly slower and more vulnerable to German fire. Tank crews reported that Cullen's devices allowed them to breach typical Norman hedgerows in less than 10 seconds from initial impact to emergence on the far side. That speed proved absolutely critical to maintaining momentum and preventing Germans from repositioning to counter each advance. Previous hedgerow breaching methods required anywhere from 10 minutes to half an hour, allowing Germans time to prepare defensive fire. The speed advantage provided by Rhino tanks gave American forces the tactical surprise and operational tempo that rapid exploitation demanded. Rhino tanks also suffered significantly fewer casualties than unmodified tanks in the same terrain. Ordnance officers analyzing loss statistics discovered Rhino tanks experienced approximately 40% fewer tank kills than standard tanks in bocage terrain. The reason was straightforward. Modified tanks didn't expose their vulnerable belly armor when crossing hedgerows, eliminating the single most common cause of tank losses in that environment. German Panzerverhust teams that had devastated American armor in June and early July found their tactics suddenly useless against Rhino tanks that drove through hedgerows at ground level. Operation Cobra's strategic impact was immediate, dramatic, and transformative. By July 31st, just 6 days after the offensive began, the 8th Corps had captured Avranches, which military historians describe as the gateway to Brittany and southern Normandy. Avranches opened routes southward into Brittany and eastward towards central France. The Normandy front, static for 6 weeks, suddenly collapsed. German forces that had fought so effectively in defensive positions found themselves unable to conduct mobile defense against American armor now capable of maneuvering freely across open terrain. American forces poured through the gap at Avranches like floodwaters through a shattered dam. On August 1, 1944, the 3rd United States Army was officially activated under the command of Lieutenant General George Smith Patton, Jr. Patton was one of the most aggressive and controversial American commanders, a man who understood armored warfare and believed absolutely in rapid exploitation and deep penetration. His Third Army's mission was to exploit the First Army's breakthrough, racing south into Brittany to capture ports and driving east toward the Seine to encircle German forces still fighting in Normandy. Patton's Third Army advanced with speed that astonished both American and German commanders. Armored columns raced across France, sometimes covering 50 miles in a single day, bypassing German strongpoints and leaving isolated German units to be dealt with by following infantry. The war of attrition that had characterized Normandy from D-Day through late July gave way almost overnight to a war of maneuver where American advantages in mobility, logistics, and air power could be fully exploited. Paris was liberated on August 25th, just 1 month after Operation Cobra began, with General Charles de Gaulle leading French forces into the city as German resistance evaporated. The encirclement and destruction of German forces in the Falaise pocket completed in mid-August, trapped between 50,000 and 100,000 German soldiers, and destroyed entire divisions' combat effectiveness. Tanks, artillery, and vehicles that escaped the pocket were destroyed by Allied fighter bombers as they retreated eastward. The Wehrmacht in France never recovered from this catastrophic defeat. Curtis Cullen's recognition came through military awards and media attention, though both carried bittersweet elements. General Omar Bradley personally recommended Cullen for the Legion of Merit, a decoration typically reserved for officers who distinguished themselves through exceptionally meritorious conduct in outstanding service. The citation praised Cullen's contribution to Operation Cobra's success and noted that his invention had saved countless American lives by restoring tactical mobility to American armor at a critical moment in the campaign. American newspapers picked up the story and transformed Cullen into something of a public figure. The Crawford Citizen and Chronicle, his hometown newspaper, published a feature article on September 7, 1944, describing how a local sergeant had invented a device that revolutionized warfare in Normandy and contributed to the Allied breakthrough. The article included interviews with Cullen's parents, who still lived in Crawford, and descriptions of his pre-war life as an ordinary young man working in the liquor industry. The tale of Curtis Cullen fit neatly into how Americans like to see themselves: resourceful citizen soldiers overcoming hurdles that had stumped the so-called experts. Yet Cullen himself, displaying the quiet humility that marked him throughout his entire life, resisted taking all the credit for what he'd created. When he spoke with his superiors, and later with reporters, he kept trying to direct recognition toward that Tennessee soldier whose casual remark had planted the seed for the whole idea. Cullen was adamant that this unnamed man deserved acknowledgement for conceiving the concept, even though Cullen had been the one who actually engineered it, fashioned the working model, put it through its paces, and showed it to Bradley. His determination to share the spotlight, while genuinely admirable, got buried beneath all the attention surrounding the invention and Cullen's growing reputation. The Tennessee soldier, historian Max Hastings called him Roberts from Tennessee, nothing more, essentially disappeared from the historical record. Even with substantial research by military historians over the decades that followed, no actual documentation has ever surfaced, proving this man's identity, his rank, or which unit he served with. The whole account hangs entirely on Hastings' single reference in his work, possibly drawn from interviews or stories that nobody has been able to verify independently. Perhaps he existed but went by a different name, or perhaps several conversations got blended into one account. Or maybe Hastings was working from hazy recollections or third-hand information. The question remains unanswered. 4 months beyond his victory at the July 14th presentation, Cullen's combat experience came to an abrupt and devastating end in Germany's Hurtgen Forest. When November 1944 arrived, the 102nd Cavalry Group, together with numerous other American formations, found themselves engaged in brutal fighting across Hurtgen Forest, a densely wooded stretch positioned along the German-Belgian border. This battle became one of America's longest and costliest fights on European soil, a battle of attrition in landscape that mimicked the bocage's nightmarish difficulty, except now soldiers faced the additional torment of winter's biting cold and Germans fighting fiercely on their own territory. On November 2, 1944, during combat operations, Sergeant Cullen was making his way through the forest when his foot came down on a German anti-personnel mine. The blast tore apart his left leg in seconds. As he fell to the ground, his body struck a second mine that tore open his right thigh with terrible force. His unit pulled him out under heavy fire, rushed him to a field hospital, then moved him through the medical system to rear installations in Belgium, and eventually across to England. The surgeons managed to save his life, but couldn't preserve his leg. Amputation became the only option. His war was finished. Curtis Cullen came back to America in 1945 to continue his long recovery. He married Bernice N. Wright in 1945 in Cranford, though that marriage would dissolve in the early 1950s. He settled into New York City life and, like countless other veterans, tried to build an ordinary future following those brutal years of conflict. He found work as a salesman for Schenley Industries, the exact liquor distributor that had employed his father for years and where Curtis himself had worked before shipping overseas. He started a family. He lived a modest life. He hardly mentioned his experiences during the war or his part in the victory that had transformed France. On January 10, 1961, just before stepping down, President Dwight David Eisenhower gave remarks while receiving the Hoover Medal from the American Society of Mechanical Engineers at the Statler Hilton in Washington, D.C. Standing before engineers and business leaders, Eisenhower chose that moment to share Curtis Cullen's story, using it to illustrate American innovation and why organizations must build systems, letting valuable ideas bubble up from any rank, regardless of formal credentials. Eisenhower, who had commanded all Allied forces across Europe and directed the entire Normandy operation from the highest levels, explained it this way. There was a little sergeant named Cullen with a thought that changed everything. His idea involved fastening enormous steel blades to the front of these tanks. When they rolled forward, those blades would slice through the hedges right at ground level. The tanks could drive across on relatively flat footing, carrying enough camouflage coverage to move forward temporarily. This concept went up the chain, presented to a captain, then a major, then a colonel. It climbed high enough that someone took action. That someone was General Bradley, and he moved on it right away. Eisenhower went on to underscore the larger point at stake. Those who understood this invention worked were probably the happiest group in all our armies that night. It preserved thousands upon thousands of lives. He added that Cullen had suffered a leg wound afterward, but remained active, working in sales in New York when Eisenhower had last encountered him. Eisenhower used that speech to teach a crucial lesson: that brilliant ideas can emerge anywhere in an organization, that leadership must foster systems encouraging bottom-up innovation, and that frequently the greatest achievements don't come from generals or credentialed professionals, but from regular people who see difficulties plainly and fix them with straightforward methods. Curtis Grubb Cullen III passed away on November 20, 1963, in Greenwich Village, Manhattan. He was 48. The circumstances surrounding his death aren't detailed in historical records that remain accessible today. Military honors accompanied his burial at Fairview Cemetery in Westfield, New Jersey, close to his native Cranford. He rested as a member of the 102nd Cavalry Group, carrying the Legion of Merit and Purple Heart among his honors. The soldier whose improvised creation had shattered the Normandy gridlock and fundamentally altered the course of the European war. Years later, a memorial stone was installed near the Cranford Municipal Building, marking his contributions to the victory. The Rhino devices continued serving American tank forces throughout the European campaign's final chapters, though their importance lessened as troops moved beyond Normandy's hedgerows into France's more expansive regions. Tanks left Normandy still equipped with the contraptions. Rhino-fitted vehicles participated in the Paris Liberation, the dash eastward across France, and even the brutal winter fighting inside Germany itself. But those ancient Normandy hedgerows, the very problem the device had been invented to solve, didn't exist elsewhere, making the steel prongs more cumbersome than useful in different terrain. British units in Normandy watched the American Rhino tanks operate and grasped their tactical value immediately. They constructed their own hedgerow-cutting apparatus, which British ordnance called prongs. Manufacturing started mid-July using the identical source material, German obstacles from the beaches, that the Americans had discovered. By August 1944, British factories had created 600 Mark I prongs destined for Normandy, where they were installed on Sherman tanks operated by British and Canadian forces. The manufacturing effort expanded throughout the remainder of summer and into autumn, producing 1,000 Mark II prongs and 500 Mark III variants for deployment on multiple tank models, Shermans, M10 tank destroyers, and Cromwell tanks among them. Even Churchill tanks, which typically didn't require hedgerow equipment because of their distinctive hull configuration, received prong installations. The narrative surrounding Curtis Cullen and his hedgerow cutter has become embedded in American military culture and tradition. Service academies teach it. Staff colleges incorporate it. Professional military education programs use it consistently as a case study, demonstrating battlefield innovation and organizational adaptability across military hierarchies. The narrative imparts several enduring lessons applicable to military challenges across generations. First, it shows how vitally important it is to nurture organizational atmospheres that inspire creativity throughout every command level. Cullen held enlisted rank as a sergeant, not commissioned as an officer or trained as an engineer. Yet his immediate commanders listened to his proposal, allocated resources to test it, and carried the winning demonstration upward through the chain of command. This readiness to seriously consider suggestions, regardless of their source, represented the American military operating at peak performance. Second, the story emphasizes what practical cleverness and direct problem-solving accomplish when facing unanticipated obstacles, work that outweighs theoretical expertise and formal training. The bocage created tactical complications that intelligence services and planning teams hadn't forecast. No established procedures addressed this terrain type. No equipment had been manufactured for bocage operations specifically. Training conducted in England before the invasion concentrated almost exclusively on beach landing procedures, giving virtually zero attention to inland Normandy operations. The solution emerged not from commanding officers or engineering think tanks, but from an enlisted man on the front lines who observed the problem, recalled available materials, and devised something workable. Third, It underscores how essential speed of execution becomes when you've located a promising answer. When Bradley gave the go-ahead for immediate full-scale manufacturing of the Cullen device, orchestrating every ordnance unit in American territory for continuous production, he transformed one sergeant's improvisation into a capability distributed across the entire force in under 14 days. Such rapid scaling succeeded only because American military supply chains and manufacturing capacity maintained flexibility for supporting sudden innovations. Under different military structures, bureaucratic reviews and testing committees would have delayed everything. Engineering boards would have scrutinized it. Factories stateside would have eventually produced it. Units wouldn't have received them until much later, long after the decisive moment had vanished. The hedgerow problem itself has become exhaustively examined within military studies, serving as instruction regarding how even high-quality intelligence can miss essential tactical realities. Before June 6th, American and British aerial photographers captured extensive pictures showing Normandy's landscape with countless hedged enclosures. Photo specialists could enumerate the hedgerows and document their measurements precisely. Yet apparently nobody throughout the intelligence apparatus or planning structures considered posing the question, how will our tanks move across this ground, and what will these ancient divisions between fields contribute to tactical circumstances? That analytical gap, failing to transform raw intelligence information into battle space implications, very nearly transformed Normandy into endless stalemate. A battalion officer, reflecting years afterward, expressed frustrations experienced across the officer corps. We rehearsed beach assaults repeatedly. We performed amphibious landing simulations constantly. We anticipated precisely what awaited us on the shoreline and prepared extensively for those circumstances. Not a single training day addressed inland combat. No simulation showed bocage fighting. We arrived in Normandy altogether unprepared for the actual conflict awaiting us, and that failure cost thousands upon thousands of men their lives. The American fighters making their way through bocage terrain during June and July 1944 endured among the harshest and most psychologically devastating circumstances of the entire European conflict. The terrain stripped away their advantages: firepower, mobility, air superiority. Casualty counts matched or surpassed the bloodiest First World War engagements. Friends fell during attacks that felt pointless, assaulting objectives seemingly unreachable. For weeks they absorbed relentless fighting. No advancement, no respite, no breakthrough appearing on the horizon, simply more fields, more hedges, more German machine gun fire. Despite everything, they pressed onward through bravery, training, adaptation, and ultimately creative thinking. They developed fresh approaches to fighting. They learned to function in settings their preparation hadn't anticipated, and when a fellow soldier produced an answer addressing their central struggle, they embraced it eagerly and deployed it to smash through 6 weeks of deadlock. Breaking out from Normandy in July and August 1944 altered the trajectory of the entire Western European theatre. From late July through the year's completion, Allied formations advanced from Normandy's beaches all the way to Germany's frontier, reclaiming France, Belgium, Luxembourg, and portions of the Netherlands. The Germans, who had matched the Allies inside the bocage, never regained momentum following catastrophic collapses at Falaise and during the frantic withdrawal eastward. German fighting strength in the west essentially collapsed. Entire corps disappeared from battle rosters. Equipment requiring years to manufacture got abandoned or obliterated. Germany's defense crumbled open. Nazi Germany's ultimate capitulation in May 1945 originated from synchronized offensives across multiple zones. Soviet armies pressed from the east, having reversed years of German advances all the way to Soviet soil and now driving toward Berlin. Allied bombing devastated German manufacturing from above, shattering the Nazi economy. Meanwhile, Anglo-American ground forces pushed through from the west, bridged the Rhine, and penetrated German territory's deepest regions. This Western campaign, which substantially influenced Germany's final collapse, got its momentum when soldiers broke from Normandy. That breakthrough commenced with a New Jersey sergeant figuring out hedgerow removal, employing scrap metal and basic metalworking abilities. Curtis Cullen's story ultimately shows what unfolds when regular people encounter seemingly impossible circumstances and decide problems aren't actually unsolvable. It illustrates organizations prioritizing practical outcomes above official qualifications, receptive to suggestions originating anywhere. It reflects the distinctly American heritage of pragmatic, hands-on improvisation, the conviction that sufficient thought and willingness to work with whatever you possess can overcome virtually any obstacle. It describes the considerable power individual effort exerts on historical development when leadership recognizes valuable contributions and implements them without hesitation. Those steel prongs, Culin welded onto a Sherman tank that July afternoon, broke far more than vegetation. They fractured a stalemate, threatening to convert history's biggest amphibious assault into a catastrophic disaster. They shattered German confidence in their hedgerow defenses and their certainty that the bocage rendered them unbeatable. They opened pathways from Normandy to Paris, from Paris to the Rhine, from the Rhine to Berlin. They demolished whatever remained of German aspirations to prevent Allied success in Western Europe. That afternoon, when Omar Bradley observed a Sherman punch through a hedgerow that had checked American progress for 6 continuous weeks, represented a pivotal moment equaling any great battle in significance. The solution, as Bradley himself documented afterward, was embarrassingly uncomplicated, deceptively basic, so basic an entire military force had been stumped by it for more than 5 weeks. Yet straightforwardness doesn't reduce significance. Frequently superior answers are simple ones. Regularly, the most lethal implements aren't the most advanced, simply the ones handling the immediate challenge. Occasionally, a sergeant equipped with a welder's torch and an uninhibited imagination achieves results that generals and credentialed engineers possessing every resource cannot accomplish. The Rhino tanks traversed France throughout summer and autumn 1944. Their steel extensions penetrated barriers appearing insurmountable, restoring American armor's mobility, facilitating swift advances carrying troops from Normandy toward Germany. These were straightforward contraptions, assembled from salvaged materials by desperate combatants in a war requiring victory. They contributed nothing to tank firepower. They demanded no cutting-edge science, no rare components, no intricate construction processes. Steel bars simply welded to tank fronts, nothing elaborate. But effectiveness, that's what counts in combat. In wartime, the apparatus that addresses the problem ranks as the finest weapon, regardless of construction complexity. Cullen pursued neither recognition nor prominence for his creation. He persistently tried handing recognition to that Tennessee man whose offhand remark had inspired him, despite that individual vanishing from historical memory. Following his discharge, he adopted civilian routines, held an ordinary job in sales, started a household, and declined speaking about military service or his role in one of World War II's breakthrough innovations. Yet historians preserve his memory. Military scholars document his contribution. Tank operators who deployed his equipment and survived engagements they might have perished in remember his name. New military generations continue hearing his story. Instruction demonstrating individual initiative and direct problem-solving capacity. Superior weapons don't necessarily mean most formidable or technologically sophisticated. Often they represent solutions addressing the actual crisis, developed by regular individuals displaying extraordinary perception, tested under maximum intensity conditions, and deployed with urgency and determination that only survival-facing societies can marshal. The Rhino tanks and their inventor represent testimony to creative thinking's dominance, organizational adaptability's necessity, and individual contribution's influence when leadership possesses sufficient judgment and sufficient courage, implementing decisions instantaneously. Curtis Cullen's elementary welding innovation fractured Normandy's standoff, transformed World War II's direction, and aided continental liberation from dictatorship. That inheritance warrants remembrance always.